All right. Page 3 for Unit 0, Lesson 6. We just talked about rates and ratios. Now we want to do proportions. So rates are a type of ratio. Proportions are a type of ratio. In fact, they are equations that are equal. When you just write 3 over 4 equals 6 over 8, that's a proportion because this equals this. A true proportion are fractions or two ratios that are equal to each other. Okay? Because they have an equal sign, you can check that they're equal to each other because 4 times 6 equals 3 times 8. 24 equals 24. These are proportions because they are equal. We've been calling them equivalent fractions. It's the same thing. Okay? What happens about fractions, these are fractions because there are no units involved. All right? Once you start putting units like ounces and servings, they're considered technically a proportion. Okay? Proportion and rates words are involved, so they're more likely to be word problems. Okay? Ratios are fractions. It's just a subtle difference. I promise not to ask you that. Okay? They're just all handled the same. This is why we've been doing all our fraction practice. Okay? Fractions will be coming up all through the course. We just really want to be able to handle them properly. All right, so Juanita had 2 different size containers of lemonade. She wants to compare the number of ounces in each to the number of servings. The number of ounces to the number of servings that can be made from each container. So then it goes on to describe container 1 has 40 ounces with 10 servings. So comparing the relationship from container 1 to container 2 and the amount of ounces or servings they're having. So this is my setup here. That's container 1. That's container 2. Are they the same? So sometimes when you're working with proportion problems, the answer is yes or no, because they're asking if there are equivalent fractions. Okay? So you can try to solve that by cross multiplication. So 40 times 21 is 840. And 10 times 84 is 840. So they are the same. So they are a true proportion. Okay. Some people, when they're setting them up, they put ounces over ounces and servings over servings, as long as you're consistent. If this side is ounces over servings, this side has to be ounces over servings. If this side is ounces to ounces, but this is container 1 and this is container 2, then you can put container 1 servings over container 2. All right, so there's a little subtle difference. You can't just, do this any old way. This is all 1, this is all 2. This is how I recommend it. This one's a little more confusing. Just make sure that this is container 1 and this is container 2. So this is container 1 and this is container 2. Okay, as long as you're consistent, you will still get your 840 and your 840, so it's still a true proportion. Okay, so let's try this one. We have 3 printers for 18 computers. I like to write them that way. One scenario is 3 printers, 18 computers. Then the other ones have 20 printers and 105 computers. Are they equal to each other? Is the ratio the same? Up here, let me erase some of this mess that I wrote on here. Sorry, the whole thing is quite messy. Sorry. Up here, how did we go from like this to this? We were talking about the fact that you didn't have to cross multiply. So 84 divided by 40 is 2.1. So 84 divided by 40 is 2.1. 21 divided by 10. Sorry for writing it backwards if that's weird. 21 divided by 10 is also 2.1. So that's enough to tell you that they are proportions. And it goes the same way. So if you're setting up the second one here, I'm going to go with this divided by 4. What is this divided by 4? 84 divided by 21 is 4. So because they're the same thing, these are equivalent fractions. Okay? So what is 20 divided by 3? It doesn't have to go in evenly. 20 divided by 3 is 6.6 repeating. 105 divided by 18, 18 is 5.83. So they're not the same. So they're not proportions. Let's check with cross multiplication. 3 times 105, does that equal 18 times 20? Let's see, 305 is 315, and 18 times 20 is 360. So no, they're not the same. So either way works, okay? It's not a proportion. This was a yes, this was a no. Let's see what this one is. It says we have a 5 wide by 8 long. Does that equal 10 wide? Oh, it's asking how long that needs to be to keep them the same. So it's asking, long. It's asking what it would take to make them a proportion. So that's not a yes or a no. The easy way would be go, let's see, let me erase this little, 5 times 2 is 10. So 8 times 2 would be 16. The answer would be 16. If you wanted to cross multiply, that would be 5x equals 8 times 10. 5x equals 80. Divided by 5 divided by 5, x would equal 16. So either way, that's what it would take for them to be a proportion, to make them the same, to make them equivalent fractions. Okay? So proportions are very similar. All right, I got to keep going here. Next thing is the U.S. Customary Units versus metric. This is what we call how we measure things in the United States. This is everybody else, okay? You know, when you pick up a ruler on one side, it has centimeters and millimeters. That's the metric system. Our inches and feet on the other side is our system, okay? So we just need a little cursory description of the metric system. It's based on a 10 system. So let's say meters are a version of length in the metric system. So this is a chart going from large to small. And so something as small as a millimeter, something a little larger is a centimeter, a little larger decimeter, decameter, hectometer, kilometer or kilometer, depending on how you want to say that. This is large and that's small. And some people need, instead of please excuse my dear Aunt Sally, they have King Henry died drinking chocolate milk, and that keeps the order of large to small. Don't need to know that. I'm just trying to explain a little bit. And that works for measurements of length, measurements of weight or mass, and measurements of volume. So when you're talking, instead of inches and feet, they have meters. Instead of pounds and ounces, they have grams. And instead of cups and pints, they have liters. Okay? And it's a very simple wording description of each of them because it's the prefix that tells you what size it is. Okay? And these are the smalls and these are the big. Okay? So that's the basics. A little more about that. So if you're talking about weight, weight is how heavy or light an object is due to mass and gravitational influences on it. If we're measuring things on Earth, then all we have to care about is that their mass and their weight are fairly interchangeable. There's a little more on that page in the Red Book. So we call things ounces, pounds, and tons. An ounce is about 28 paper clips. A gram in the metric system, their basic unit, is really only about a 1 paper clip. It's a lot smaller, okay? Pounds are 16 ounces. Like a quarter pounder, there's like 4 hamburger patties in a pound. Kilometers, though, are quite large. There are about 9 hamburger patties in a kilogram. And then we have a ton is about it's 2,000 pounds, which is about 1 small car, okay? Units of length, there are more examples on these pages if you want to see more. This is the fast version. When we're measuring distances from one end of the object to another, or the distance from one object to another, or how long something is, we use inches, feet, yards, and miles. These are things we use to measure them with. If you had a millimeter or millimeter, that's about 1/25 of an inch. That's how small that is. Centimeters a little less than a half an inch. Meters about 3 feet longer than a yard. Kilometer is a little more than 1.5 miles. Volume. U.S. system is in capacity, metrics in volume. Capacity and volume are kind of like weight and mass. There's a little distinction between them. Volume is considered the space taken up by the object itself. Capacity refers to the amount of something, okay? There's a nice link there. If you are into science, it's kind of a different kind of thing. So in the U.S., we use these. In the metric system, you mostly hear about these. A milliliter is 1/30th of an ounce, or about a quarter of a liter. A liter is a little more than a quart. So a liter is less than a gallon, okay? And when people market their products internationally, they tend to default to the metric system on their labels. So that's why you're buying a 2-liter soda, or maybe they're not going overseas and they're selling you a pint of ice cream with so many ounces in it. So it just depends how they're marketing their product as to which one goes on there and where they're from. That's a whole nother thing. That's a business question. So that's the basics. All right. So what do we care about? We are going to be converting units of measurement in a system. You will be given the equivalent units, so we don't have to memorize any of those, okay? We're just going to convert one type to the other. We're going to use the factor label method they tell us in the book. I'm going to start with, this is more practice there, I'm going to start with an easy one so we can kind of get the hang of this. So if you are asked how many inches in 3.5 feet, okay, you're provided a conversion factor horizontally. 1 foot equals 12 inches. And then there's 2 different ways to use that conversion factor depending on how the question is asked. Okay? So you're going to be, for every problem, you're going to be given a conversion factor and then the question. Okay? So what I like to do is write the given down that's in the question. And then I'm going to use the conversion factor next to it, and I'm going to multiply them. So I'm going to give them both as fractions. So let me explain a little more. So if it says how many inches are in feet, then this is 3.5 feet, and I put it over a 1, every single one of them. And then I multiply that by the conversion factor turned in the fraction form that I want for the problem. So the question is, do I want 1 foot over 12 inches, or do I want 12 inches over 1 foot? It's very specific. They're not interchangeable. Since this one gave me in feet, I want to be able to cross out the feet. So I want to put the feet at the bottom. So I would write 3.5 feet over 1 times feet, because I want to get rid of the feet. And they want instead inches. So I put the inches on top. And then I go back and look at the conversion factor and find out that the 12 goes with the inches and the 1 goes with the foot. So that's how I put it. So this turns into 2 fractions that I'm multiplying across the top to get my 42 inches. Okay? 42 over 1, we want to write that as 42 inches. All right, those you need the units for. This one has a little typo. That's supposed to be 6. All right, so 156 inches are the given. Okay, so if it gives me inches, I want to be able to reduce it with inches. So the inches go down here, the feet go up here. The 12 still goes next to the inches, and the 1 still goes next to the foot, and I multiply across the top and get 156, and I multiply across the bottom and I get a 12, and I'll check in my calculator. 156 divided by 13 is divided by 12 is 13 feet. Okay, so it depends on how many units they're given as to which way the one conversion factor is going to go. Okay, so let's try these other ones. Let me go to the bottom for a second and do the conversion factor ones. Right here, it says how many milliliters in this many liters. So they're given 2.7 liters. Okay, put that over 1. Put a multiplication sign. Go over here. So this is the given. And then the conversion factor, they said, is right here. So they gave me liters. So I want to get rid of the liters, so I put that down here. Okay, and they want milliliters instead. And according to this, there's a 1 next to the liter, and there's 1,000 over there. Okay, so I'm multiplying across, and I'm going to get, make sure I don't do any typos here. I'm going to get 2,700 milliliters. And I want you to take a minute and make sure it makes sense. You're given liters. That's a big quantity, and we're going big quantity to little quantity, right? So it makes sense. My number's going to go from, I have, a 2-liter Pepsi and 0.7 of another one. How many milliliters is that? That's a small unit. So it makes sense that the same quantity is going to have a much larger number if we're going to measure it with something smaller. Okay, so the same thing can have 2.7 liters in it, or we're going to say it has 2,700 milliliters in it. Okay, so we're going from big to small. It would make sense our number went up, okay, for the same item without changing its measurement. So let's go over here. Something measures 2,359 milliliters. You can write out the whole thing. I don't need proper abbreviations. You just can write out millimeters. Millimeters, sorry. Put a little dot, put that over 1. What is the measurement in meters? So I want to get rid of millimeters, and I want meters instead. I look up at the conversion factor, and it says the 1 goes next to the meter, and the 1,000 goes back to the millimeter. So this is going to be 2.357, and I have to stop the tape. Oh, God. Okay, so hopefully I was able to pause that and I came back and it's still recording. All right, so let's see. If something measures this, then how many does it measure in that? So don't forget to write meters in there. And then a little logic sense. Let's see. We are taking something small. Millimeters is a very small measurement. And we want it in larger chunks. So it makes sense that this big 2000 number is going to get smaller because we're measuring it with something bigger. Okay? So that's how we did those. So let me go back to the top. And let's see, write the rate in fraction and lowest terms. So we have that number in 3 bottles. So that's going to reduce. Let's see, how do we reduce this? Is this number divisible by 3? Let's see, 2 plus 2 plus 5. Wow, that's really horrible writing. I'm going to try a little harder. 2 plus 2 plus 5. 7, 8, 9. That's a 9, which is divisible by 3. So that number is divisible by 3. Certainly this number is divisible by 3. And you get, what? 750 milliliters over 1 bottle. Let me write that over here. Oh my goodness. So, where was I? So you could write 750. They didn't ask for a unit rate, but it is a unit rate because it's over 1 bottle. So there's milliliters per bottle. Okay. Simplify the rates of cans of soda compared to people. Let's see. That ends in a 0. That one ends in a 0. Ugh. So this is how I can do videos. I got so much other stuff going on. Sorry for the interruptions. 80 divided by 5 is 16. 45 divided by 5 is 9. Let's see. In a 16 is 4 and 4 and 2 and 2. And 9 is just 3s and 3s, so we're good. That's it. This would be 16 cans of soda per 9 people. So that's not a unit rate, but they didn't ask for one, so we're good. That is a rate. 16 cans per 9 people. Enter a ratio as a fraction in lowest terms. So this many minutes over 88 minutes. Let's see, they're both even. I can divide by 2. Divide by 2, that is what? Let me get my calculator. 112 divided by 2 is 56 over 88 divided by 2 is 44. They're both even still. Let's keep going. 56 divided by 2 is 28. 44 divided by 2 is 22. Ugh, they're still even. Divided by 2 is 14. Divided by 2 is 11. Ooh, that looks good. That is a ratio as a fraction in lowest terms. 14 minutes to 11 minutes, or just 14 by 11. Let's see. 9 minutes for a pulse. What is his rate if he counts 783 beats in 9 minutes? Let's see. Is divisible by 3. 7 plus, hold on. 7 plus 8 plus 3 is 18, which is divisible by 3. So that's divisible by 3 also. So that's 3, and 783 divided by 3 is 261. 2 plus 6 plus 1 is 9. That's divisible by 3. So keep going. So 1 over 261 divided by 3 is 87. Checks his pulse for 9 minutes. What is his rate if he counts? So that would be minutes. So this looks a little funny to put it this way. In 1 minute, he beats 87 beats. So that's acceptable. It sounds a little funny. You would say 87 beats per minute. So it's perfectly acceptable to go 783 beats per 9 minutes. And when you reduce it, you're going to get 87 like that, and you can say 87 beats per minute. So either way, mathematically speaking, is correct for a rate, because it doesn't have the 2 in there. He checks his pulse for 9 minutes. What is his rate if he counts this many beats? So it really doesn't say this to that. So either way is fine. I want to say the ones on the test are not obscure like that. So I think that, remember, the test is going to be on everything we've done since day 1. So there's very few of each kind. So hopefully they're very, when we go over the review, you can tell that they'll be a little more specific. All right, recipe for oatmeal cookies. All right, let's finish this. We have oatmeal cookies. We have 5 cups of flour over 6 cups of oatmeal. How much flour is needed for a big batch of cookies that uses 18 oatmeal? 18 cups of oatmeal. So remember, if I did flour on top and oatmeal on the bottom, then this side better be flour and oatmeal. So watch where you're writing it. It matters. Okay? So you can put an X there if you want. And then you can cross multiply or just make equivalent fractions. Right about now, somebody's thinking, can't I just put 5 cups of flour over 8, I don't know, cups of flour equals 6 cups of oatmeal over 18 cups of oatmeal. So let's try it both ways to double check that, okay? So this way, let's see, 6 times 3 is 18, so 5 times 3 is 15, so X would be 15 cups of flour is needed here. And if you, let's see, this one's a little harder because it's 5 and 6 together versus something in 18. So let's see, you can still do that though. 6 divided by 5 is 1.2. So 5 times 1.2 is 6. What times 1.2 gives you 180. So that makes it a little weird, sorry. That's why some people cross multiply. So let's do this one, cross multiply. 5 times 180 equals 6. Oh, that's not an 80, that's 18. Sorry. 6x, 5 times 18 is 90. 6x divided by 6, 90 divided by 6 is 15. So, bunch of ways to do that. And just for a check, 15 times 1.2 is 18. Okay, so this is oatmeal, not 180. All right. So any way you want to do that, there's like 5 different ways to do this problem. So I set it up as this is one thing, this is another thing. Some people go with apples to apples, kind of oranges to oranges kind of thing. So either way, it does work. Okay. I'm going to have to erase to make room for the other thing. So just back up the video if you need to see that again. Oops. Okay. So 5 miles in 50 minutes. Wants to know how far 80 minutes will go. So over here, I decided to make miles on top, minutes underneath. So over here, no matter what's going on, this has to be miles on top and minutes underneath. If you did it the other way, the math will still work out, but it has to be, like if you did minutes to miles, then you have to do minutes to miles over here. But I did miles to minutes, okay? Units need to be the same. And then, let's see, if she walks 80 minutes, so that means the 80 goes here, and this is the one I don't know. So bunch of ways to do this one. You could do 5 times 80 equals 50x. I don't know that I did it that way, so let me do the math. Let's see, 80 times 5 is 400 divided by 50 is, I did not do that right. Hang on. 400 divided by 50 is 8. Let's check by doing it the other way. So 80 divided by 50 is 1.6. So 50 times 1.6 equals 80. So 5 times 1.6 equals what? 5 times 1.6 equals 8. So x equals 8. Either way. All right. Last one down here. All right. Suppose you work for a large coffee, blah, blah, blah. So we're looking with proportions. We mix, here it is, 90 pounds of this with 60 pounds of that. So 90 pounds of that with 36 pounds of that. And then we want 20 pounds of the K. 20 pounds of that equals how many of that? So you can put an X there or a question mark or whatever. You can use the cross multiplication if you put an X there. 20 times 36, 90, 20 times 36 is 720 divided by 90, x equals, you can reduce them, let's see, 720 divided by 90 is 8. Wow, that's also 8, so let's check doing it the other way. 90 divided by 20. 90 divided by 20 is 4.5. So 20 times 4.5 gets you that. So something times 4.5 gets you this. So you'd have to go 36 divided by 4.5. Well, yeah, that gets you 8 over here. So double check. 8 times 4.5 gives you 36. So x equals 8 either way. Either way, you need 8 pounds of Kona as your final answer. Okay. Solve the proportion. You can cross multiply to solve, or you can say 9 times 2 is 18. So this times 2, 162 times 2 is 324. Be nice if you put n equal. All right. I think that's it. Hopefully that worked.